Hey, hello, welcome. We are done with SMO round one for this year. And I'm not going to keep you in suspense, lah, right? You have long enough week, well, half a week, but feels like a full week. So let's just say it, right? I think the cutoff is going to be not far from last year, for most things. I think that the experience that all of you have for the paper is quite different, mainly because there are clearly some questions on the Olympiad side and clearly some questions on the A level side. So if you are not a JC student, there is no reason why you would definitely have studied calculus and vectors and complex numbers, and that would imply that you have a significant number of questions which you may not be able to do at all. On the other hand, if you are more of an A-level student and you are a bit newer to Olympiads, you will find that there are some questions which you can easily do, but then there are also some questions which are very much specific to Olympiads which you have less experience with. And so if you're in the intersection of you have A-level knowledge and Olympiad experience, I think you will find the paper pretty easy. But because this is the SMO Open, that intersection is not that large. So uh, another thing is, of course, to do with the questions with slightly dubious handling. We can continue to vent frustration at the SMS. Obviously, it seems that there have been some overflow of issues from senior, but this is not as bad as senior. Uh, However, if you took senior, I guess you kind of get Vendemon for free, right? So we'll talk about that later. Uh, and yeah, I think that it is also fairly similar to uh, last year uh, in style, but of course the exact questions are a bit different. Okay, so uh, remember that of course for the SMO Open last year, the cutoff was 16 for round two. So I'm just saying that I think he may be a touch lower, but not by that much. Because if you have anyone who is familiar with Olympiads, without A-level knowledge, you can get 15. If you're familiar with A-levels content, with only a bit of Olympiad knowledge, you can get 15. I'm not saying it's guaranteed, I'm saying you can. So that is roughly where I would estimate it to be. However, I think it's a paper where it's quite hard to get more than 20 for anyone, because there are some legitimately very difficult questions. So that is what I will comment in general. We will get into the questions. I will talk about what's going on for Q4. We will talk about the mishap for Q10's question. We will, I guess, thankfully, uh, not have too many other weird things to talk about, but we will focus more on the questions proper. And at the end, we can see whether we still agree that these are reasonable cutoffs. Okay, but before anything, just if you just took the SMO Open, in other words, you're not watching this in 2026 in the morning before the SMO round one, and you are actually, having just taken it, just take a deep breath. You have successfully gotten through the SMO season, whether you only took Open or Open and something else. Whatever it is, what is done is done. We can kind of just take the next couple of hours just to, learn a little bit of math. Okay, so question one. We'll get straight to it. Okay. Sorry, I typed floor and I jump scared myself. The equation absolute value of x squared minus x equals to k has four distinct solutions for k between a and b. Find the largest possible value of the floor or 4 times of b minus a. I think we get the sense that the SMS or the question setters are getting a little bit frightened of making mistakes, and so they just kind of like have floor and absolute values everywhere, even when they're not necessary at all. Now, this is quite an easy question if you have seen this idea before, which is just that you draw the graph, and then this is looking at a horizontal line. And so x squared minus x, we know that is actually a straightforward quadratic. We know that the roots are 0 and 1. And then we know that the negative part gets reflected over by the absolute value. We also know that the axis of symmetry is at 1/2. And so therefore, the range of horizontal lines is just going to be between this and the x-axis. So this point here, when you sub in x equals to 1/2, is 1/4. And so this is half 1/4, and therefore a is 0, b is 1/4, and your answer is 1. I feel like the thing about this SMO Open is that for the recent few years, these are kind of like textbook A-level style questions, which means that if you are in, let's say, Sec 3, Sec 4, you have a lot of knowledge of geometry, combi, and number theory, it may not really help you for some of these kind of things if you have to figure them out on the spot, right? They're not impossibly hard, but it takes time if you have not seen them before. So if the Open continues to look pretty similar as it has for the last few years, largely, I think the last few years of papers will give you a rough sense of the kind of A-level style topics you need to know. It's not hard, it's just that you don't want to spend the time in the contest thinking. Okay, now same question 2, it's a graph question and it's asking for area, you just draw the graphs. X squared plus y squared equals to 1 is your unit circle. Absolute value of x plus absolute value of y is 1. You can see that this is going to be fully symmetric because plus or minus x plus or minus y doesn't change anything. So in the first quadrant, it's just a straight line from 0, 1 to 1, 0, and then symmetric over both the x and y axis. So it's just a square or a diamond. So unit circle, pi minus 2. Okay, so floor of 10A equals to 11. Okay, now question 3 is calculus-like, but you can do it without calculus. So you can do it with calculus, but I think we have the actual mention of calculus later with the integral. And so I'm going to put off the calculus and just do it in the most elementary way possible. Now, first we need to understand what the question is saying. The question here is saying that you have got the graph of y equals to 1 over x. So another graph, right? Clearly, whoever is setting the question is in the mood to ask a few of these. 1, 1, we know where that is. 2/3, 4/3 is... Now, the funny thing is that this is kind of irrelevant, right? Because why are you telling me about this tangent here? I mean, like, Oh, so it's just mainly to make sure that t is the other one, but it's not really useful, right? It's just sort of like here is the other one. So if this is your 2/3, 4/3, then you're kind of saying that I want to have another tangent line, which means actually kind of like draw the tangent line from here to there. We mostly are not going to know hyperbolic geometry, and certainly we don't need it anyway. Just simple coordinate geometry is that I want to find the line such that it has exactly one intersection with the curve, right? Because I can see that this tangent line will not intersect the other side. So it will have exactly one intersection, and I will look at the equation and see how it goes. Okay, so this line, by your point gradient form, is like this. And then, of course, y equals to 1 over x, being the curve, have one intersection. So this is great because if I just substitute 1 over x in, then it becomes something that can be made into a quadratic. I can do my discriminant stuff and everything should be good. Okay, so multiply both sides by 3x. Okay, and then discriminant should be equal to 0 because there is one intersection, means there is supposed to be one root x for whatever the m is. Okay, so good news is that this is straightforward, quadratic, no ugly stuff happen, and the question did not mention a flaw for once, so it had better be nice. Okay, so get m equals to -1 or -4. Now, it's quite clear that the -1 is this, right? This is the gradient -1, the one that goes through 1, 1. So you can just substitute in m equals to -4 back in to find out what is x, because the value of x is just the t. Okay, and so x equals to half. So that is the point there, which turns out to be t is half, so it's 1/2 2. Again, I'm not using calculus. If you used calculus, you can find the derivative and then sub in t, and then after that solve for what t equals to here. That is the calculus method. This is the non-calculus method. The SMO has their bad points and their occasional mishaps, but they do try for the SMO Open to make sure that at least there are some questions which can be done using the A-level method and also using so-called more elementary methods. So they try. Oh yeah, I forgot to write the answer down. The answer is just 10 times half since this is your half there. So answer is 5. Yeah, so as I'm saying, the SMO has their good points. They are often trying to make sure that since everyone can take the SMO Open, although a question may be such that calculus is useful, they also want to make sure that calculus is not always necessary, except for the explicitly like integration and differentiation and limit questions. Yeah, we will deal with question 10 later, but of course we can deal with the question 4 issue first. Okay, so I think if you have been reading the chat, you have some idea what's going on. So let me just say out what is most likely going to happen, which is that the question is most likely going to be voided, and that's because there are multiple solutions. Exactly how many solutions are there is not very important to it, because if there are more than 2 solutions, it does not make any sense to say we'll accept any of these 5, 6, 7, 10, 12, whatever there is. Makes no sense. Now, I believe we roughly know what the question setter was going for, because as many of you realized, when you sub in, this is basically saying 1x1 cubed, 2x2 cubed, 10x10 cubed. Many of you realize that we know the sum of cubes formula, and we can check. Because the sum of cubes formula is just the square of the sum. And this is 3025. And so it implies that if you see 3024, well, x1 equals to 0 and xi is 1 otherwise, works, because it's basically just saying that 3024 is 2 cubed plus 3 cubed until 10 cubed. But as many of you also realized, either during the contest or after discussing with your friends after the contest or right now in the chat, you realize that the 1x1 cubed, there is no necessity for x1 to be the one that is zeroed out. Right? So it means that, for example, x1 can be 10 in order to take the place of 10 cubed. And then after that, the x10 becomes 0 instead. Or you can, of course, have, let's say, x2 be the one that is, sorry, yeah, x2, let's say, can be zeroed out. X10, actually, the x10 can be 1, and then the x1 can take on that row instead. You can even do some more exotic shuffles. Meaning that, for example, you can let the first one take on the row of like 2 cubed, the next one take on the row of 4 cubed, and then the next one take on the row of 8 cubed, and then you kill off the 8 or something, right? You can sort of like have x1 equals to x2 equals to x4 equals to 2 or something, and then x8 equals to 0, and then xi equals to 1 other. So basically, there are way too many solutions, and clearly they all give different sums. So I believe that perhaps the question could be fixed by saying that you say that this is a non-decreasing sequence or something. Maybe there was some missing condition, I don't know. But clearly there are too many different answers that it doesn't make sense to give awards for these set of answers, because there's too many. So yeah, that is the SMS's unspoken mishap, because I don't think anyone will receive any correction for this during the contest, right? So I'm just going to just say that this should be avoided. Whether everyone gets 1 mark or doesn't get 1 mark makes no difference, right? Because it will increase everything by 1, but in relative terms, it makes no difference. So that is the irrelevant consideration there. Well, it depends whether this was meant to be an easy question or not, right? So what was the intention of the question setter? We wouldn't know. We, uh, it certainly cannot be how many are there because there doesn't seem to be any trivial way to handle it. It would be just a very long-winded bash, so I don't think it can be that. Okay, question 5. Right-angled triangle has integer side lengths p, q, and q plus 1, where p is less than q. Um, this here is quite interesting on the geometry note, right? Because there's like kind of like not a single diagram in there, but there is geometry, just no diagrams because the geometries are kind of like not the the circle geometry like cyclic quadrilateral angle chasing kind. So again, clearly this is the coordinator's preference, which is more computational geometry. And so one of the things about computational geometry is just that we want to make sure we have enough equations for the number of variables and we are fine. If we have enough equations for the number of variables, then it becomes our algebra skill, right? So equation number 1 is obviously Pythagoras. Okay, and then equation number 2 from the in radius is using your area crossover. We had the senior question with the in radius mentioned just yesterday, although with its own set of troubles. So your area is a good interchange for finding this kind of information: in radius, circumradius, angle, side length, because so many formulas have to do with area, even x radii as we pointed out yesterday. So area is half PQ, but it's also equal to RS, where S is the semi-perimeter, and now R is 2025. Okay, so if I move the 2 over, this is what we get. It would be potentially possible to solve it just from this equation to some degree and get a list of possibilities using our Simon's favorite factorizing trick. But we don't need to because p squared is 2q plus 1, so we can just substitute that in, cancel off a p, and then things should be nice. Okay, so now we have got a second equation that looks like this. So I can just substitute this into here, and that will give me a quadratic in P. The one good thing about some of these questions is that you know when you have done it correctly, because it is very unlikely that you will coincidentally end up with a quadratic that works so nice. So it is quite clear that this is very, very factorizable. Okay. And so 4051 is our numerical answer. Okay. Question 6. This is almost free mark for any of us who have done recent SMO papers from not just junior, senior, open, anything at all, because this idea is recurrent, that you have got even powers and a 0. Even powers are non-negative, therefore the only way is that they are both 0. Uh, it's quite obvious that, yeah, I mean, this is telling you x is equal to y. So this is telling you x cubed equals to y, which is now equal to x. So x equals to just 0 or plus minus 1. And the largest would be, well, 1 or minus 1 is both okay. I have nothing else to say about this question, so let us continue on. Question 7. This is Vandermonde, which we saw in the senior yesterday. Well, some of us saw in the senior yesterday. I am not sure whether there is any degree of cooperation between the people setting senior and open, or is it that the same people propose questions senior? We don't really know, but like it does seem that there is occasionally overlap between the sections, right? This has happened even in like overlap between open round 1 and junior round 2, by the way. So if any of you are taking junior round 2 here, even if you may not have done super well for open round 1, I would say that it's useful because they do grab ideas from open round 1 for junior round 2. This is one of the weird things that happens. But anyway, we talked about Vandermonde yesterday, so just to not assume everyone has seen it, we will mention it as an independent video, sorry, as an independent statement here that one of them can be changed to 20 choose 20 minus k. And now if I were to say this thing in a counting explanation, this is actually counting the following. For k equals to 0 to 20, the number of ways to pick k out of 20 items in, let's say, group A, and 20 minus k out of 20 items in a group B. But if this is for all possible k out of 20 and 20 out minus k out of 20 is just the same as 20 out of 40. Because every possible way of picking 20 out of 40 involves some number out of 20 and the rest out of the other 20. And so it implies that it is just 40 choose 20. So this is your Vandermonde example. Now, by the way, Vandermonde can be used in many other situations. Let's say if it were the sum of, like, it doesn't have to be this, right? If let's say it were this and like 18 minus k, then it will become 40 choose 18. So Vandermonde doesn't actually just have to do with this square one. It's just that this is one very specific example that the SMO like this here. Also like the senior paper, you open up the thing here, but unlike the senior paper, this one now has a different answer extraction because 20 factorial squared y is just 40 factorial, and it now asks you to just find a number of zeros at the back. Which is straightforward enough, but it's just a different way of getting the conclusion out. So 40 factorial, the number of zeros we know comes from the number of fives. That is technically your Legendre's formula, but many of us just have known it for a long time without knowing the name as Legendre's. So there are 8 multiples of 5, 1 multiple of 25 in this list, so 9 zeros at the back. Decimal representation just means base 10, so that is not anything to worry about. Okay, we will go up to question 10 because certainly if I go to break before going to question 10, there is going to be the only thing we're talking about. So we'll go up to question 10. Okay, so number 8. This is the only like normal kind of like traditional geometry question that's shown up in the Open this year. I mean, it's not a bad traditional geometry question. It's just like the only one. It also has no diagram, so let me take this opportunity since it's the only time where the diagram I can say a bit about it. Let me say something about drawing diagrams. Your first attempt at a diagram should just be very rough. Right? Just anyhow draw something and then there is no need to be to scale, like just kind of like scribble it and then just see what happens. So you're like, okay, F is the reflection, and then like angle C is 40 degrees, FAH is 35 degrees, and then you're like, okay, so the question asks you for angle A, which means that this is probably wrong. This is too messy, so we'll draw a better one, but there is nothing too much to worry about as long as my FAH doesn't look too weird, and I can also just accept the 40 degrees to start. Okay, so draw a very crude one. Take note of what sort of things that you will focus on the next time, which is like, oh, D and E are midpoint, so actually by the midpoint theorem, it should be parallel, and then after that we can draw a better one. In fact, don't erase it before drawing the better one. Just draw the better one at the other side, which I suspect that maybe angle A is not that far off from what we've drawn because at least this looks acute lah. Okay, so we'll draw a neater one. We also can control the order of our drawing a bit now. So like draw the midpoint thing nicely, note the parallel. Okay, it's quite okay. And so let's now the first thing I'll do is I will kind of want to transport anything that I can obviously transport. Okay, so this 40 degrees definitely comes up here because of the parallel lines due to the midpoint theorem. There are some other things like, let's say this would then be like 50 and 40 degrees down here. Because this is right angle when you are reflecting over. Okay, I mean, I can put some more 40s and 50s, but I think we will worry about that later. Now, the other thing that we need to know here is just pretty classic, which is our configuration with the midpoint in a right-angled triangle. And that's namely that these will be equal by Thales, basically angle in a semicircle. Right? That's where you have the midpoint and a 90 degrees. So these are equal. But there's a reflection. So this actually also is equal to this. You guys know I've talked a lot in various times about using a bit of color, right? Use some color to highlight things that are equal in a diagram, using literally a highlighter or your blue pen, green pen, purple pen, red pen, whatever color you have. That tells us that, oh, actually this is a very blatant circumcenter and a cyclic quadrilateral. Yeah, this is one of the rare times where the circumcenter comes from literally the fact that there are 4 points which are equidistant to it. And so once you have that cyclic quadrilateral, we suspect that we should be able to move things around a fair bit. But actually, I don't really need to move things around too much. I can move it around a lot, but I can just move this 40 degrees over to there and I'm done. that's your angles in the same segment, please get used to doing it, especially for round 2, but even for round 1, because it is annoying to draw so many circles. Get used to finding the angle properties of circles without actually drawing the circle. So A is 40 plus 35, 75 degrees. Yeah, I'm sure some of you guessed it with 40 plus 35. It is not entirely possible to yeah, if you guess something like this, because if you know for geometry questions, if they only give you 2 angles, it must be related to those 2. You draw one that look half decent, you can potentially guess. Yeah, what are you allowed to bring? I don't know about protractors, honestly. Ruler and compass, definitely yes. Protractors, like many other things, it seems that every school has their own way of saying yes or no, because it's not in the official SMO rules. So just for future reference, just put it in your bag, and then if let's say that your teacher says cannot, then cannot. But I don't think it would help that much for this question, because you will need to know what angle A is to accurately draw the triangle. Right? So in a sense, unless you try 10 different accurate drawings, and your accurate drawing is really accurate, which is possible, but a huge waste of time. Okay, question 9. Complex number, root of unity. This is quite funny though, because it is again like question 3. Not necessary to know anything about complex numbers other than the fact that you are not only restricted to omega equals to 1. You just need to accept that there are other things, and you don't actually need to understand anything about them, all the roots of unity, exponential form, all this. Don't need to worry. Why don't need to worry? Because actually, if you just take this, you can just factor out omega minus 1. Yeah, if you want to say WW, this is the Greek letter omega, which is normally used for complex numbers. Whoever set this paper is a stickler for like correctly chosen Greek letters, because there's omega here, and then there's like mu and nu in question 11, and yeah, but anyway, this is omega. You know that this is not the one that we are taking, and so therefore it's this equals to 0. That's enough. Because if that is 0, then this is literally just that thing plus 9. See, no complex number. So I would say that for future reference, right, 2 things can be true. 1, of course, you can go and learn your vectors, your complex numbers, your calculus, and all the other things that I described as A-level content. The other is that if at this moment when you're taking SMO Open, you don't know those A-level content, or a few days before the SMO Open you don't know it, there's no point cramming all of it down. Still look at the question and think whether I have a chance, because this is just algebra, even if you have no idea what omega actually is. In fact, this is better than using the exponential form and then using the geometric series and then realizing, oh, it's 0 anyway. Okay, let's now talk about question 10, right? So now this is the corrected version, which I understand to be the consensus, majority but not unanimous consensus, because I know that the original question was a minus 1 squared, and then some of you seem to have heard a minus 1, some of you seem to have heard floor a minus 1 squared, and all kinds of things. Some of you did not notice there was any problem with the original question. Some of you noticed it after your teacher mentioned, some of you noticed it before your teacher mentioned it. Now, is the question going to be voided? This one, I don't know. Because this is a correction that I think, correct me if I'm wrong, we did the first hour or so some schools started to inform their students, right, from what I understand, like within 1 hour, which means that the SMS must have sent it out within 1 hour. However, clearly not all of you were informed or informed correctly. So I don't know what's going to happen for this. Okay, I have no way of confirming it. It is impossible to tell, but let's just talk about the question, all right? And so what do we think happened? Now, the funny thing about this question, you're not finding it very funny anymore, but like I say the funny thing about this question is that some of you didn't see any issue because you did it in the quad jump way and you potentially did the same mistake as whoever the question setter was. Right? Because there's no way that the typo is between a square and a floor, right? That's not a typo, that's a mistake. So, and then y minus 1. I think we kind of can guess what happened, right? So this is your circle. You want a point on the circle, and then x squared plus y squared, you know it's related to the distance from the origin. So you're like, okay, the furthest is down here, and then you're like, okay, this is 0, 0, this is 2, 2, so this is square root 8, and then this is 1. So it seems that the original thought was that a equals to square root 8 plus 1, except that that's not correct, right? Because that's actually that's the square root of x squared plus y squared. So that's probably why the original question was a minus 1 squared, then there will be 8. But then, of course, it was observed by whoever, and many of you, that doesn't work because actually x squared plus y squared is this, or if we write it, is this, right? So this is actually your A. And so now that is A, the correction that it seems they chose to make was to floor A minus 1. And of course, if it's floor A minus 1, we can compute it. Right, so this is 5 point something, between 5 and 6, so it would be 13. I don't know if it's going to be voided, but for me, it's that I never really had this mishap because what I did was a trigo substitution. So let me distract you all from this voiding discussion just by saying that trigo substitutions also work for something like this. You can let x equals to 2 plus cosine theta, y equals to 2 plus sine theta. By the way, did anyone notice like the fact that like trigo seems to have disappeared? Right, I don't know what is happening for the SMO this year, right? It's just very mysterious. Yeah, so this is your x and y in the trigo substitution, and then this is actually something I like to do because if let's say it were 2x squared plus y squared, you can't do this anymore, but you can still do the trigo substitution. Right? So that's why I normally will use the trigo sub. So I'm just mentioning this because also, again, this is a resource for next year, right? If you're watching this in some future year, it's good to know that this method exists too, rather than we are all just caught up in the annoyance of they're going to avoid this question. Okay, so you can R formula this thing, a trivial application of R formula, because it's just the 1-1 case. So this is the way that I got 9 plus 4 root 2 first. So I was very confused by the question because I went straight to the R formula thing. I didn't immediately realize it was root 8 plus 1 squared. Then only after I tried the quad draw method, then I sort of figured out what went wrong with the question originally. Okay, so that's all I have to say about this question. You can continue to express your frustration, but just know that the SMS has the liberty to like change their mind. It's not that they have made up their mind in advance. So if let's say that they realize this, they may choose to void it if they find out that too many schools didn't get the info. Okay, so this one we will see. Okay, but we'll take our first break here, where I'll rest my voice a little, and then we'll come back and look at the middle section, which is actually quite interesting. Okay, so let's just answer a couple of things. First of all, when I mention this, I mean excluding the question 4. Am I including this question 10? Honestly, I don't know if I'm including it or not, because I wasn't aware of the extent of the misinformation or the lack of update. Right? So as I said, this is before the review. If it really turns out that many of you did not get the update, I guess you can reduce this by 1 and take it as that is voided potentially, but if it turns out that it's included, we can't help it. Uh, so like I thought that it was only 1 or 2 schools, but apparently it's more than 1 or 2 schools that did not get the information, right? So this is something which I would not be aware of until now. Um, on my part, like I said, of course, I am not in your school, so I don't know what happened. I believe that the SMS sent out the correction pretty early because some schools got it pretty early. But I will, well, for whoever I know in the SMS, I will just let them know anecdotally that there are a number of schools that the update was not given or was not given correctly. And then we'll see what they do because obviously I don't get to decide. If I get to decide, I can't do this anymore. Uh, to answer the actual question again, right? Because everyone is so talking about the voidedness of it and not actually, maybe I did not explain it so clearly. X squared plus y squared. So by right, the square root of x squared plus y squared is just the distance to the origin. So it means that if you want the furthest point from the origin, that's how you get the largest possible value of square root x squared plus y squared. Right? So you pick x, y down here to be the furthest away, and the distance is you go from 0 to 0 to 2 2, that's root 8, and then the radius is 1. So that's where root x squared plus y squared is root 8 plus 1 at the maximum. That's for the the solving of the question itself rather than all the other logistical issues. Okay, let's move on for this. Okay, I think there's other things for us to discuss. Yeah, I would also very much like a SMO paper with no errors. I have had my fair share of SMO papers with errors when I was a student, and now when I'm a teacher, it seems to be something that does happen a bit more often than is ideal. But let's not worry about that, right? Because at least as far as we know, for the rest of this paper, there aren't any errors except for the Q19, which obviously I think was announced for everybody, changed A19 to A9. So I hope that one is not a problem. But other than that, I think we are fine. Okay. Let's come back, and when we're coming back, we are on vectors. I feel like this is a question that appeared in SMO about 8 years ago or so, like with different numbers, of course. It is saying that you have a plane, you have got this 6, 1, 2 plus lambda 1, 0 minus 4, that is this vector. It hits the mirror, and then it is reflected. This is, of course, what reflection means. The first thing about vectors to say is that, of course, for something like this, if you don't know anything about vectors, you can't solve the question. The second thing about vectors is that you still have to trust that the question is nice, although I know trust is a rare commodity now, but trust that the question is nice. In spite of what has happened, do not go around assuming every question has an error. There are many different question setters. It cannot be everyone that propose questions to the SMO make errors, right? So it's nice. And so how do we do this nicely? Well, the first thing I need to do is that I want to find out any point on the reflection. Because if I know any point on the reflection, that is already good enough. And so if any point on the reflection is good enough, actually, what I can do is that I just go through pick a point and then reflect it over. But the funny thing is that, but then if I pick up, how do I know whether it's gone through? Actually, even if it's not gone through, it's still okay, right? So if let's say the point you pick has not gone through it, and you pick, let's say, the one that is still on this side, you reflected it, that's also still on the same line. And so therefore, all I'm going to do is just basically take 612 and just reflect it over the plane. I will get one more point on the reflected ray, and then we are fine. The way that you get the reflection is to get the midpoint, which is the projection onto here. We know that the normal vector of this plane is 113. And so you know that this point is 612 plus, let's use an unused Greek letter, mu times 113. And you want that to lie on the plane. So I just substitute it into the equation. You solve it, you will just get the rather unsurprising but nice mu equals to 1. So mu equals to 1 means that therefore this point is 725. But you actually want this point, so you just add another 113 to it. So this point, add a further 113, you get 838. And therefore this is the thing that is on the ring. Now, of course, you would be able to find a point, but this is just how the like this 516 is not actually unique, right, for vector equation of a line. 516 happens to be this point actually, by the way, where it hits the mirror, so it's not really going to be useful, unfortunately, if you went to find out where it hits the mirror. Okay, so you compare the components. Obviously, this means that this is not V, this is the Greek letter nu. Nu equals to 1, and so A equals to 2, B equals to 2. And I don't know why they put absolute value there. Okay. Question 12. Now, this is nice idea, very annoying calculation, and also it seems that we have, for those of you who took senior yesterday, another unwelcome ceiling again. Seems to be a trend this year, right? With like sometimes floor, sometimes ceiling. I don't know why it's sometimes floor, sometimes ceiling, when they can just standardize it, but they have done another ceiling again. Now, the question is not as horrible as some of you thought it was. However, when they go and give you something to 4 decimal places, there's still a chance that at the very end you still have something horrible to do, which turns out to be the case. However, it is not horrible like everywhere. Okay, so let me explain. The first thing that I want to do is that I want to just let these two things be A and B. So if you don't want to expand it, great. I also don't want to expand it. These are conjugates in the sense that I don't really want to describe, but it's like it vaguely has conjugate-like properties because of the fact that there are a couple of swaps. Yeah, I was looking at my phone just now for a second. Believe it or not, people just keep on texting me about nothing but question 10. It's, yeah, we are all in the same boat, okay? We'll deal with this later. Let's focus on the math first. Enough people are probably trying to complain to SMS by now. A plus B is what I'm going to try to exploit because you're going to get 2 root 5 over root 2, which is root 10. That's one nice thing about conjugates. The other nice thing about conjugates is you can multiply them. This turns out to be nice too. So great, this actually is quite well chosen. The only slightly annoying thing is that why did they have to do 8? Could they have done anything else other? Yes, that's unfortunate. So we have to basically just keep on squaring and repeating. Okay, so a squared plus b squared. This is 10 minus 2 root 6, and then you go up again to the 4th power. You can't avoid this, so this is the annoying part. Okay, let's fast forward that a little. And then we square it again. Let's Yeah, then this is an annoying calculation. Yeah, so yeah, am just thankful that they didn't forget to give you an approximate value of square root 6. But there is otherwise not much redeeming qualities here. Times this 2.4495. As far as I know, there isn't any way that you can do this estimation reliably because this is to the nearest of 1, so and your times 8960, so you have to actually just do that calculation there. And this is going to be 124 point something lah. So the numerical answer is 125. So it's a nice question in terms of the first part of it. And if they actually were just keeping it to like A4 plus B4, however, I think a lot of us would just have expanded it and not realized. So they went for this. Okay, question 13. This one's actually calculus. It is, however, when you see floor, floor functions are kind of just there to like be a nuisance. Not talking about the final thing to give you an integer answer. I mean, as part of the question proper, they are just there to be a temporary nuisance. But normally it's quite okay when you figure out what is really going on. So what is really going on here is just that this is the integral from 1 to 3. And so from 1 to 3, the floor of x is only 1 or 2. So it's just two parts. This is a normal integral. Okay, so 2 ln 3 minus ln 2, which is ln of 3 squared over 2, so 9 over 2. Okay, then that's your b. Yeah, so some of you came in a bit later on the note of cutoffs again, right? The reason why I would think that it may be slightly on the higher side is you must just understand that like 90 people last year was around 90-ish. For open is really few. I mean, if it stays the same, that's really few because why? Uh, that would be like if it's 90 people, you'll be thinking of let's say the top 10 year ones and twos, the top 30 year threes and fours, and the top 50 year 5 to 6. That may be a rough ballpark estimate. If you are in those respective levels, you know how good are the top 10 people in year 1 to 2, the top 30 people in year 3 and 4, and the top 50 in year 5 and 6, right? So you kind of know that. And for year 5 and 6, that means all the JC knowledge is there. So that's why I will always skew a bit higher for open until a time comes when they suddenly decide to allow 150 people to take round 2, then of course maybe it will be lower. But if it stays as last year, that is the kind of ballpark estimate I have. Okay, question 14. I feel like I've seen this exact question and I took it as a student in 2011. I do not have that book right now. I just remember 2011 because 2011 had a lot of weird things in the SMO. As some of you know, the junior paper was weird, the senior paper was weird, open paper was weird for a lot of different reasons. So I feel like I remember this as from being a participant then, and also having looked at it one more time in the last year or so. So I remember that it was kind of like a troll question. This is not a calculus question, it's a troll question. Actually, I don't need to draw that. I mean, it's a triangle, but I don't really need to draw the triangle. More important is just that there are different number of students at each location. So why is this a troll question? Is because if it weren't 100, 200, and 300, you really would potentially have to do something pretty clever. I will say that like it's actually not that straightforward to let's say pick the point. Let's say even if there were 100, 100, and 100, that would already not be so straightforward, and this is foreshadowing. But because it's 100, 200, and 300, basically if you just want to say pick some point p, the thing that we want to find is 100 px, 200 py, 300 pz. 100 plus 200 is 300, means that you can group together like this and just use the triangle inequality on both. Now, thankfully, of course, they didn't ask you to calculate this because otherwise the question will have one more problem. This is not that. This one is just that the equality case, because you want to find out where it is that by the triangle inequality, it means that P is on xz and yz. If P is equal to z, you can just put it there. Nothing is stopping you from having P down there, and so that just means that the point is 0, 300, and the answer is 300. Yeah, you can guess this question. If you have done plenty of practice all the way back, maybe you have seen it, but I remember that as a student, I also guessed it, and then only later realized it's the triangle inequality, so maybe you can too. Okay, 15. Once again, we have to know our limitations, which is that this is a really potentially horrible equation. 2x cubed plus x minus 3 cubed is this degree 9. So it has to be very special. But I can't even expand it because, well, I mean, I can, but it's not going to have any nice features. And in fact, the original form seems to be nicer than if I were to expand it. Here's what I'm thinking of this. I'm thinking of this as like, I'm going to want to do a sort of like a unsubstitution in a way. Like I feel like as if this is actually some weird thing cubed. I'll call this y, and it's like it actually came from x cubed plus y cubed equals to 3 and y equals to 2x cubed plus x minus 3. So this is what it seems to look like. Then I realized that if I move the 3 over and I replace the 3 back by this, I will get something symmetric. Which is that y plus y cubed equals to x cubed plus x. You can go and group them together and factor it again now, but I can also just say that actually I know that the function x cubed plus x is increasing. Not a calculus thing, it's just that x cubed is increasing and x is increasing is enough. So therefore, fx equals to fy will imply that x equals to y, which you could guess anyway, but this is just to confirm it. So therefore, this thing here equals to y is actually just x, and so you get 2x cubed equals to 3. 16. This looks like a junior question from one of these last 2 years, right? There was with a different set of coefficients, almost the same idea. Except I think maybe even easier than the junior question. Because you can just subtract. And then you know that they're distinct, so you can divide by y minus x. Okay, so once you have this, there are a lot of ways to resolve. I think I like the fact that it is symmetric. I think I like the fact that it's symmetric, and therefore I'm going to just sort of say that if I sub in y equals to minus 2 minus x into here, it gives me a quadratic x squared plus 2x minus 1 equals to 0. And I know that I can also do the same thing for y. Which means that actually x and y are roots of that quadratic. And you can get xy equals to minus 1. Now this is like the systematic way that I get it. There are lots of different ways, but I will try to find something that I know is going to work rather than sometimes things like what we just did here may feel a little bit magical. And if I can think of a better way than magical, I would. So hence for this one, no, the best way I could think of is this. But for this one, I'll just go with, I get x plus y, I realize it's symmetric, they will end up being a quadratic, Vietas, and then I know Vietas is going to work for sure. So x squared minus xy plus y squared. Okay, and so you will end up with 16 as your numerical answer. Yeah, correct. If let's say you reach this point, of course x and y can be found. So I mean, there's a lot of choices for how you want to finish. Right. Question 17. Consider all possible real numbers a, b, and c such that a plus b plus c equals to 0, a squared plus b squared plus c squared equals to 12. Find the largest possible value of a to the 4 plus b to the 4 plus c to the 4. First of all, let's address the question, right? The question of, yeah, why doesn't Cauchy-Schwarz work here? Cauchy-Schwarz will always tell you the truth about a restriction, not necessarily that it can hold. So if let's say you said something like a to the 4 plus b to the 4 plus c to the 4, let's say you said something like this, it will just tell you this, and two issues, right? One is that this is not actually pointing the right way because it asks you for the largest. This will only tell you it's at least 48. Secondly, even if you found any other way of using Cauchy-Schwarz, the equality case is generally a equals to b equals to c, which is certainly not going to be true here. It doesn't really look like it. So That's why Cauchy-Schwarz will not work. What I'm going to do here is that I believe there is some algebraic identity that can get here. However, I said just now that I like to do things systematically in a way that is quite reliable. So I would say that the way to get a lot of these identities is using the Newton's identities approach via Vieta's. So that's quite reliable, and I'll just show you how it works. Now, a plus b plus c equals to 0, a squared plus b squared plus c squared equals to 12. You can, of course, square it is still 0. And so if you subtract off the a squared plus b squared plus c squared, you will have 2ab plus bc plus ca equals to negative 12. So this is negative 6. Now I'm then just going to push it to Vieta's. A, B, C are roots of. Now sum of roots is 0, so there's kind of like a blank. The pairwise sum of product of roots, the sum of pairwise products of roots is negative 6. And the product of roots A, B, C, I don't know. So I'm just going to just say K, right? Where K is A, B, C. Now from here, I can get to the fourth power already, because this means that now I was expecting to be doing some inequality stuff from here, right? It's just that I found a way to write it in terms of the lower degree stuff, and then I was expecting something to happen, except I realized that, oh, so if you now just go and sum this over ABC on both sides, you just get a to the 4 b4 c4 is 6a squared plus b squared plus c squared minus k times of a plus b plus c, which you realize, oh, actually I don't need k because it's 0. So it's actually equal to 72. No inequality needed. It is that. After I saw this answer, then I remembered actually that, oh yeah, this was an idea that is quite a cute identity that appeared in various contests over time, which is that actually if you were to just substitute in c equals to negative a plus b, and then you have got this. It just turns out that this is an identity that, in retrospect, I remembered. There are a lot of identities, so that's why there's no way that we know all of them. It's easy to verify, but difficult to discover. Okay, so of course this will also give you 72. So if you have seen this before, this was in, I think, I've seen in American competitions, but in SMO Open, I literally saw in the year 2000 or 1999 or something like that. Okay, so that is not an inequality question. Okay, question 18. Now, let's talk about one more issue. This is not really like error, but this is one of those cases where I think some of you asked, like, what is the procedure, right? So in this procedure, does the procedure refer to the product or the increase and the product? To which my answer is, I'm not sure. It would seem to me that if the question says that he performs this procedure k times, each time having the same product, I would think that the procedure refers to calculating the product. But if your understanding is that the procedure is that the same way again and again, so it was referring to increase by one, I hope they accept both answers. But my understanding is product is the procedure because calculates the product and then each time having the same product. This is a pretty easy question to guess because first of all, you think, oh, if it's all positive, then the product will just keep getting bigger. Then you start thinking, oh, maybe there's some negatives. But then if there's some negatives, then something will change sign, and then it becomes from negative to positive. Then you say, no, then I make sure that a few things change sign at the same time. Then it's like, and then this is getting very complicated. Then you realize, actually, I should just let it be zero, right? Because if I let it be zero, then I don't have any of these problems. And so a very simple way is just that I make sure I have a zero on each turn. So it's kind of like you just say that, okay, at every turn I have a zero, it's like you have got minus 99, minus 98 onto zero. Then after that, the next one is minus 98 to 1, minus 97 to 2, and then all the way until it's 0 to 99. Now this way, you will get 100 zeros. As in 100 product zeros, and so you have k equals to 100, or 99 if you wanted to define it as the increase. Okay. If I were taking the SMO open, I would probably say, yeah, there's no way we can do better and move on. But the proof is short and sweet, so I think it is worth mentioning how the proof works, which is simply that if you let the numbers initially be just A1 to A100, then basically after n, what do they call it? N times of doing this procedure. So after n iterations, you have got and so we know that this is a polynomial in n, and therefore if it is a degree 100 polynomial, it can only repeat the same value at most 100 times. Right? Because basically I'm saying that px equals to a constant means that px minus c equals to 0 is a degree 100 polynomial. It has at most 100 roots. So therefore, you cannot do better than 100. Okay, so all right, I think this is the end of that second page. So it's a pretty natural stopping point. So we can take a quick short break and then we will come back for the last 7 questions. Right, so let's come back and look at the final 7 questions corresponding to the last page of your paper. The SMO cutoffs, everything. Please note that whatever I'm saying is not official. It's never been official. I'm fairly certain of the correct answers, meaning that's just mathematical statements, right? So we can be fairly certain because if I made a mistake and it was obvious, some of you have told me as well. In terms of like all the logistical stuff, let's say here, are they going to accept 99 and 100 or only 100 or only 99? I can't be sure. I just think that in from my past understanding is that if it's like a correct question, just that there are two reasonable interpretations that like in this sort of way they will accept both. Uh, if it is like a question like which just has a whole ton of answers that like question 4, it doesn't make sense to only accept a few. So like it may end up being voided because that's just completely not unique. And this is just my understanding, it's not official, and same with all the cutoff estimates. Okay, let's continue now. This is a typo at 19, which I believe you were informed of. A9 instead of A19. I understand this one was pretty early on that everyone was informed. So it's also pretty impossible that they told you the wrong thing, because if they told you B9, you'll be like, that's nonsense. How am I supposed to find B9? And then if they didn't correct it immediately, I'm sure that someone would have asked until your teachers corrected it. This is kind of only possible for things near the boundaries, which is either the highest or lowest degree stuff. You can't just sub in values because A9 is kind of like not going to be able to be separated from everything else. So you can't just like put in x equals to -1, minus half, all this. It's not going to extract out A9. What we can do for this is just, well, there's A9x to the 9. That's where it is. I have to make use of the fact that it is going to be involved in the very high degree terms. So the highest degree it reaches is x to the 10 times this. So I guess compare the x to the 19 coefficient is what I want to say. So binomial theorem on this side. Now we just trust that it's going to cancel out nicely somehow. Right? And so there is A9. But there's also the 10x to the 9 times this. Okay, so there's actually two things in here. Never mind, A10 is even easier to find. So I just compare the x to the 20 coefficient. Right, that would just be x to the 10, and here, so that's literally just telling you that A10 is 2 to the 20. And lo and behold, you realize that if you just move 1, 2 in to the power, this is 0. So, great. Small tip in practice is that we don't want to keep on calculating everything inside. So if you see 2 to the 19 to the 20, please don't calculate that immediately. And even if you happen to remember that 2 to the 20 is 1048576, that's not like something that you should actively be putting in anyway. You want to make sure that you only do calculations when you're forced to, because the SMO is perfectly capable of making you multiply 8960 times the square root of 6. So you know they're going to make you do that sometimes already. Don't go and do extra calculations that are not necessary. Okay. Question 20. It's another one that is like asked to death already in the SMO junior, senior, and open over the years. It's also been a junior round 2 question with different coefficients rotating around. It is just pretty classic. Perhaps with the only caveat here that if you happen to only have seen one example, like say, okay, let this be equal to n squared, and then we complete the square, and the only example you saw is where the coefficient is even instead of 15, then you might think that there's a problem here. Well, there is no problem here. You still complete the square anyway. And then you just multiply by 4 so that there is no more fractions in anything at all. Multiplying by 4 works also because then 4n squared is still a perfect square. So you are able to write it as a difference of squares. And there's a 101 in the junior paper yesterday, right? The 101 is prime when we did a factorization like this also, I think. So this is 101, this is 1. It's the largest possible. So technically you also could have the other, but clearly that's not better. So you don't have to worry about the negative case. However, that's technically a thing too. Okay, so we want the largest possible, hence only worry about this combination. So you can sum the two and you will get x equals to 18. You can put it back in to just check and if you put in x equals to 18, you get n equals to 25. Personally, if I wanted to check my answer for something like this, 18 is small enough that compared to all the other calculations we have done, just put in x equals to 18, check whether it's 25 squared. Whenever you have an ability to check an answer with substituting back, please do so. Okay, anyway, this is actually quite a nice problem. It is so funny that like the problems at the last few are actually pretty nice and are also sort of like, it seems that for 21 to 25, that's where the like the so-called unusual problems have been stashed. Not all equally difficult, I'm just saying unusual problems. Some of them, however, are easier to guess, some of them are easier to estimate, and some of them are easier to do various things on. Okay, so we'll talk about them as we go through all of these. For 21, how many ways are there to delete a unit square from an 11 by 11 square board? I am just going to leverage technology to insert an 11 by 11 grid because I don't think I feel like drawing it. It is technically not necessary to draw the 11 by 11 as a grid, but let's just say that it will make the explanation a lot clearer. If you already know what to do, you can actually kind of do it without a grid, but only kind of, because as you will see, it still is a lot more helpful if we have it available to us. Now, for all these kinds of tiling questions, first of all, obviously, 11 by 11 is 1 to 1. So yes, if you remove one tile from it, you are left with, sorry, one square from it, you're left with 120. That's divisible by 3. So it's not surprising that you will need to delete the square. But for all of this, it is not guaranteed that you just delete any square and it's going to work, where the most like classical example of this is your checkerboard coloring. When you have your 8 by 8, you remove two opposite corners. You cannot tile it with dominoes because you have more black squares than white squares, or vice versa. So it's not just multiple of 3 that's the condition. It's not that all the 121 ways will work. It's also a little bit tricky to actually test them because it takes quite a while. And so I would like to narrow it down first. And so for 1 by 3 and 3 by 1 tiles to basically all be treated as the same, you can do this, well, we'll call it coloring, but it's actually just labeling. Now it's just, I'm writing it like this, but it's actually more like going down diagonals. And so on, but no one is going to want to write all of that down. So let me just say what we're trying to do. We're just trying to see how many 1s, 2s, and 3s there are, because every tile is going to cover a 1, 2, and 3. Now, if we to do the coloring like this, we know that in the up to the 9 by 9 point, there will be clearly the same of all of them. And then each of these 2 by 3 portions will also have one of each. So you will be left with this, which if we were to count the diagonals, 1, 2, this is 1, this diagonal is 2, so this just to show, right? So this is what's happening. I'll just go down this way again. So you'll see that there's extra 2. So there's 40 each of 1s and 3s. Therefore, you must remove a 2. But it doesn't mean that all of them will work. So if you look at it, it actually doesn't feel like all of them are going to work. And so if it doesn't look like they're all going to work, how are we going to actually be sure? Well, I'm just going to highlight the diagonals. Because now I'm just looking at the tools, right? So I'm saying that the one that I delete must come from one of these. However, if I were to just rotate this thing 90 degrees, the same logic applies. Which means that if the same logic applies after you rotate by 90 degrees, this this all of these are also going to be possibly also have to be where you remove your squares from. And so if you look carefully, you don't get confused. The actual ones that are on both the yellow and the pink diagonals are only these ones. And so this is leaving 9 possibilities, but by symmetry, we kind of suspect that if one of them works, most of the others will also work. And so now we can try this, but it is actually quite simple to handle. It's simple to handle because if, for instance, I pick the one at the top left corner, I can just finish the 5 by 5 surrounding it, and then everything else is going to be, the sides are multiples of 6, so you know that you can just use horizontal and vertical tiles accordingly. Okay, and you can shift this 5 by 5 around, and the same thing will work. And so therefore this confirms that the answer is actually 9. It is guessable, but only peripherally guessable, like meaning that you have to take quite a while experimentation before you can guess. So if you did manage to guess it, you also did quite a bit of work, so congrats to you. But here's the proof and the construction. Yeah, of course, if you this is just showing it with all the colors just so that we can see clearly. You want to go and like label it as coordinates, you can always say that label them as coordinates where one of these diagrams where x plus y is something mod 3, x minus y is something mod 3, you can, but I mean that will be even less illuminating most likely. And the construction we have no choice lah. I mean, to see whether they work, we still need to kind of put these ones in. Okay, 22. I told you the setter this year likes Greek letter, so now we have the Greek letter phi. Not the phi the phi function for your Euler's torsion function. This is just let M be the set of mappings. Now mappings are just functions, right? Maps and functions kind of mean the same thing. That's not 100% precise, but it is close enough. And usually, if it meant something else, they will define it to you. However, I do not actually want to think of this in a way, because what are C1, C2, and C3? I think of it as just there are 4 things, and I am just coloring the numbers 1, 2, 3, 4, right? As you see C1, C2, just see colors again. Phi1 is not Phi2, Phi2 is not Phi3, Phi3 is not Phi4, Phi4 is not Phi1. This is going in a loop, and so therefore I'm just going to draw it as a square. You can draw it as a circle or a square, and I'm just saying that I am going to assign each of these with one of 3 colors so that the adjacent ones are not the same color. Now when you say it like this becomes a downgraded version of the junior question from last year. If you remember, there was one about coloring regions, right? This is downgraded because it's only 4. So the junior one, there is the solution that involves splitting into cases, the solutions that involve recurrences, but this is just 4, so you don't really need any of those. How you want to count this is up to you. Let me give you one suggestion, but really there are many. Right, so I will split into cases based on this diagonal. So I can still use their notation now, right? So if phi1 equals to phi3, there are 3 choices for what they are, and then the other 2 have 2 each. If they are not the same, then I have 3 choices for phi of 1 and 2 choices for phi of 3. And then the 2 others, there's only 1 choice left because they cannot use either of those 2 colors. So just 6 ways. And so it sums to 18. This is actually one of the features of the SMO Open, which is that there are some times where they just make an easy question sound way too complicated. And it is sometimes just because they're being annoying, but sometimes it's actually because do you understand how to visualize abstract looking notation? It's extremely important actually in math in general to be able to find a way of visually or like intuitively conceptualizing all the weird symbolic things that you see. So I mean, it does have some useful feature in terms of like what we do in math. Uh, but practical for SMO is don't look at the question and assume it is scary, therefore I should skip it. Because otherwise you end up pretty annoyed again. Oh yeah, I realized we started at 3:30, so this is not going that long either. I think we will be done below 2.5 hours again. Okay. Now, question 23. This is another one that is partially guessable. Uh, if you are talking about guessing, and I am talking about guessing, it's always referring to it in the sense of guessing a feature or an approach, not like literally guessing what the answer is. You have to still do something. Now, the first thing that I will do is, of course, I have to deal with this a 2025 equals to root 1 plus root 1 plus a 2025. I feel like this was in one of the recent, I want to say 2022 or 2023 opens, there was one that had sort of like a nested square roots like this as well, right? And basically, what we were able to conclude is that if you iterate it, it is a fixed point of the function, in this case fx equals to root 1 plus x. I can say that, but because it's just two square roots, I'll do it in a simpler way. Is it doing that? Sorry, things lagging quite a bit. Give me a second. So the thing about writing pads, I have no idea where my cursor is when it starts lagging. Okay, I'll just ignore the fact that Microsoft Word is not happy with the SMO open either and is insisting on doing everything very slowly. Okay, so this is what we have. You can actually kind of cancel it, but I was just write down the thing after squaring first, right? Because there's no point putting a square root there. You can cancel off a 2025 plus 1 because the sequence is positive. And I can tell that whatever I'm getting, there is going to be a constant term that's 1 on both sides. So it's quite okay. Okay, so if you expand it and cancel the 1, okay, and also it is non-zero. So you can cancel it one more time and you end up with this conclusion. So this is without having to invoke any function stuff, you end up with this. Two things are interesting about this here. The first thing that is interesting about this is that this is basically the same thing I'm asking for. So it is like a 2025 squared minus a 2025. This is a1 squared minus a1. The second interesting thing is that I realized that there is no reason why, because this only uses an plus 1 in terms of an. It doesn't use more previous terms. So there's no reason why I cannot go backwards and write an in terms of an plus 1 and go down my sequence in reverse order. Now, what is going to happen that I don't know. I mean that I'm just not going to go and write down a 2025 is equal to 1 plus root 5 over 2 and do anything with that number. I just want to see how does it look like when you do the U-turn first. Okay, so it will be quadratic in an. So let's just check that. Remember, you're solving for an in terms of an plus 1. Somehow I like to complete the square for things like this rather than to blast the quadratic formula. I feel like that has a higher risk of error. But that's completely subjective. So you end up with an. This looks familiar. Wait. So that means that if you put in n equals to 2024, I don't even need to go and make an the subject. While getting there, I realized that it's just that this is 0. So it means that a 2024 equals to a 2025, and then you can just backtrack by the same logic all the way to a1. And so this will imply that the whole time, a1 squared minus a1 minus 1 is also equal to 0, and so that's why your answer is 1. Okay, so some of your algebra may be a bit longer, a bit shorter than mine, may look a bit different, but fundamentally the logic is just this. You want to go backwards, therefore you will be involved in trying to write an in terms of an plus 1 so that you can do like sort of a reversed path, because in effect this is just an plus 1 is a function of an. You're just finding the inverse function. But it turns out to be a lot nicer than one may expect, because it's a constant sequence. So good for us. Okay, where did the question number go? There. Microsoft Word does not like the SMO open very much. Okay, let's improvise. Two sequences here. Just now is one sequence, now we have two sequences. We are clearly having increasing sequences. And we are asked to find the smallest positive integer such that AK is greater than 100. Means when does it go past 100? Let's try. When you are doing sequence questions, if you can test values, test until you're getting quite annoyed. And then if you are getting quite annoyed, see if there is anything like a redeeming feature that makes it not so bad. If somehow it's actually not annoying, then that's even better, because you notice something nice immediately, then great. Okay, so I look at this here, I can have A1 is 50 and 1 over 27, B1 is 27 and 1 over 50. Okay, if I want to calculate the next thing, then I need to make it into an improper fraction. Is it? Oh, it's the same thing. Oh, that's interesting, right? Now that's interesting because you realize that, I mean, this is not just true for this. So after one term, if you didn't immediately realize it, you kind of realize there is something nice about this. At least one nice thing about this, which is that if I were to put them both like this, it actually means that an plus 1 over bn plus 1 is still an over bn, right? If you divide this, you get 1 over bn, 1 over an, and then it swaps around. So it means there is a common ratio, which is 50 over 27, but this is common ratio between the two sequences. This is not like common ratio in the sense of geometric progression. If you substituted in like n is equal to 50 over 27 bn into here, you will get a pretty ugly version of yet another SMO open round 1 problem in the past, which I forget the year of, but it was something like a sequence where an plus 1 equals to an plus 1 over an, and then you wanted to know when that sequence like goes past like like 100 or something like that. I don't remember exactly. No, this one's 100, some other number. But that's a bit more ugly. Sorry, this is a bit more ugly than that. If you were to do the substitution, actually there's no need to do the substitution. We are happy with this because of a couple of things. First of all, AK is greater than 100 means that it is going to happen at the same time as BK is more than 54, because that's the fixed ratio. Secondly, now this is the thing that you kind of need to observe, is that your other nice thing that you have with an plus 1 over bn and bn plus 1 over an is that you can multiply these together. A bit of intuition is this. It's kind of like as if, yeah, I know that actually an plus 1 over bn is more like an plus something over an because of the ratio, and then we know that we always like to, like, you know, x plus 1 over x, we like to square that, right? So it's kind of like that. You can multiply, you get a and bn, you get 1 over a and bn, and or you just get this and this, and they're both 1. I thought that I may get an over bn, but of course that will not happen. But I get something that is even better. That's just an over itself, bn over itself. This means that your product is increasing at a controlled rate. It is increasing to and something that is really tiny. How tiny is it? The starting product is 1350. So it's basically 2 and something less than 1 over 1350. That's very tiny. Therefore, that's quite safely negligible. We can just check, right? Because my target is going to be if and only if the product goes past 5400, and 5400 minus 1350 divided by 2 is very happily 2025. Have there been other 2025s in this year's paper? Yes, for senior, for the throw rectangle question. But you get 2025. However, let's just not jump into it. Let's make sure it actually works. To make sure that it works, we know that clearly this means that A 2025, B 2025 will be more than 5400, which works, right? So we know that this is enough. We need to just check before that whether those tiny things are enough, right? So let's hope that it is not yet reached 5400. It is 1350 plus 2024 times 2 plus at most 2024 copies of this thing. Oh, that's less than 2. So great, that's less than 2, meaning that the gap is far away enough that it has not yet reached 5400. And so this confirms that our answer is really 2025. Okay, finally, 25. Let m be the minimum value of the function here. Now, there will always be one or two unpredictable questions in the SMO Open, so I thought briefly, is this something where they're trying to make us do multivariable calculus? And then, of course, two things helped me to quickly realize that's not true. The first is that that would be horrible. And second, that these are too nice already. If we have ever seen an equation of a circle, this looks like the equation of a circle expressions. But when you try to complete the squares, it's even better. So clearly, these are not randomly chosen stuff. Now, I then tried to kind of get some triangle inequality-like thing to work, but I can't. When I say triangle inequality-like thing, because all of these geometrically can be represented as distances. So that has been asked before as a SMO Open question. You know, that I'm talking about has been asked before. At the end of the day, when it comes to Olympiad questions, it is always a common thing that we take an idea we have seen or we have said before, and then we just twist it a bit. So this looks very much like that, but it doesn't really work if you try to form three right-angled triangles and line them up. You can't really line them up in a meaningful way. Also because there are three things that are distances involving x. How can you have three distances involving the same x and y? Unless it's actually just one point x, y. And these are actually just distances. Now we have distance to 0, 0, 4, 0, and 2, 2. Just now, as I mentioned, foreshadowing, right? Question 14 was the version where you throw with the triangle inequality. So it actually kind of makes sense from a meta perspective. They're not going to make you use the triangle inequality again. This is actually a legitimate geometric task. You cannot say, oh, then I'll use the distance form. You came from the distance formula. So we are trying to do it geometrically. We are now not doing it algebraically anymore. So what is happening is that we have got, this is, in case it's not immediately apparent, a 90, 45, 45 triangle. So, sorry. So it's a special case, which is just as well, because if it is non-special case, you may not be able to do it so nicely. It is 0, 0 to 4, 4, so this is 4, this is 2 root 2, 2 root 2. Now, it is once again quite guessable, however, that your choice, if let's say that you picked this point here, now Microsoft Word loves the SMO. If you make this point here, the total distance is 4 root 2. Ceiling of 4 root 2, we have calculated this just now, much to our chagrin, is 6. If you had, let's say, picked the midpoint down here, you're going to get 2, 2, and 2. You also get 6. And so it is pretty easy to guess the answer is 6. If you took anything in between, and you're asking for the minimum value, it seems that the best you will do is still 5 point something. let's just confirm the explanation of this. The explanation of this rigorously is that the point where the sum of distances is minimized is just simply the Fermat point. Of the triangle, if we just label ABC just for naming purposes, Fermat point of triangle ABC. I had a student, and maybe some of you have seen that, like that for SMPF, there have been projects done on Fermat points. There are lots of properties of the Fermat point, but the property that we need to know is just that it's the point where the angles formed are all 120 degrees. That is the location of the minimum. If any one of you has, on the coding side of things under Euclidean graphs, this is actually also the solution to the Steiner tree problem for 4 points. So this is the minimum location for any given triangle if you are just trying to find the location where the sum of distances is minimized. Incidentally, the fun thing about the Steiner tree problem is that this actually works if you Google it, just Steiner tree bubbles. Bubbles, like soap bubbles, actually solve the Steiner tree problem, which means that the soap bubble can solve this question too. If you just take 3 things and then just dip the whole thing into the 4 poles of soap, you will see this 120-degree angle. However, we are not concerned about soap, so we can just do this pretty normally. If we want to get the length, we can just say that this is 2, 2 over root 3, 4 over root 3, and so you can get the distances of this. Yeah, this is 2 minus 2 over root 3. Your m is going to be actual value is 2 plus 2 root 3. So this is actually what the minimum is. However, of course, this thing, the ceiling of it is still going to be equal to 6. So all the previous guesses are still not wrong. Great, so we have come to the end of this paper's discussion. As with junior and senior, I'll ask you the same question. Do you feel that the cutoff projections are fair? Not fair? Well, you can have your own suggestions, write it in the chat. I said at the start that this paper is kind of like, there's like the A-level section and then there's like the Olympiad section, right? Which means that for anyone that has knowledge of enough of those A-level like topics and also knowledge of like enough Olympiad classics, you can get 20 plus if you have enough of both. I say can, not as a guarantee. But if let's say that someone who is particularly competent in one direction and not the other, you will end up with a lot of scores that are like slightly in the a bit more than 10, because there's 10 questions that can be said to be A-level like and 10 questions that said to be Olympiad like. So you have a lot of people in that 14, 15 range. That's where I am projecting from. But obviously some of you will beg to differ. I am not able to confirm again about the voiding, so let's not talk about that anymore. I would just say that from the looks of it, the SMO Open round 1 is not meant to be like impossibly hard. So if you are preparing for round 1 in future, don't just focus on very esoteric things because clearly some of the classic topics are also important. If you're not sure whether you will make it into round 2 and you're not from the SIMO team and therefore you don't get to take it unofficially, if you're in J2, of course, I leave it to you. If you're in any level other than J2, I'll still encourage you to take a bit of the time to look at some round 2 questions for open. Read the solutions if you have no idea how to make progress. They are interesting. And also, even if you end up doing it next year, you can't just jump in, right? So results for round two will most likely be out in about 2 weeks' time, is the average, but it has been sometimes almost like closer to like 3 weeks. So it can't be closer to 3 weeks because junior senior open at the same time, even though open round two is 1 week later. So maybe like 2 weeks ish. We'll see how long it takes, especially with all of these things that probably your school teachers may be complaining about all the errata from the SMO. So if it takes a bit longer, then do start looking at round two questions. They are interesting. Of course, if you're starting now, you won't be able to do that much in 1 month, but it's possible to actually make enough improvement to like sort of like have a chance at doing one more question than whatever you would think you're able to do right now. Okay, so that's all I have to say. Yeah, I will leave the chat open as usual for about 5 more minutes or so. If you have any questions, let me know. Despite all of the weird things that have happened, I hope you enjoyed the papers. It's not bad. In terms of the questions, they did not go wrong, right? So we have to separate that from the mishaps. I think they are fairly interesting. Okay, so I'll go off camera now. All the best, of course, if you are hoping for any of these awards. But either way, do start looking at some round two stuff. Okay, so go off camera, and probably the next time I'll see you is when I'm just recording some stuff for round two preparation.